Hi, Audiomovers. How are you? It's so nice to be with you again. And you're just in time. I'm here with the fantastic students of Beecroft Garden Primary School, as well as someone really special. Would you like to introduce yourself?
Hi, I am Tania Marques. I am one of the astronomers at the Royal Observatory Greenwich.
Hi, Tania. That's a really cool job. You know, it's amazing that you're here. We have all been talking and wondering about the sun, and we have so many interesting questions. Maybe you can answer some of them for us. Let's start with a big one. Can you tell us, what is the sun?
Great question. Let's start with what is the sun, since we're talking about the sun today. The sun is a star. A star is this object in space that is a big ball of very hot gas, mainly made of hydrogen and helium. So the sun is our source of heat and light, and that's what makes life on Earth possible. Now the sun is just one star in many stars that are part of our galaxy, the Milky Way. And in our galaxy, we have about 400 billion stars, and the sun is just one of them. And we are one planet orbiting that one star in one galaxy. And then the universe is filled with trillions of galaxies, and each galaxy has billions and billions of stars.
Hi, my name's Chloe and I'm 9 years old, and my question is, how was the sun made?
Hi, Chloe. Great question. The sun was made in a cloud of gas and dust called a solar nebula. And so a solar nebula is like a massive or giant cloud in the galaxy, and it collapsed under its own gravity. And when it does that, it makes it spin faster. So this massive cloud of gas and dust collapsed under its own gravity. It starts spinning faster, just like pizza. When you know pizza will flatten out when it starts to spin, and that's what happened to that solar nebula. It collapsed, it started to spin faster, and then it flattened out. So most of the stuff that was part of that solar nebula went into making the sun. And everything else, all the sort of the leftover stuff, went into making little blobs around that flattened disk. So those were the planets. And everything else was left over after the planets were formed.
I didn't know the planets were made from leftovers from the sun. Is that why the Earth orbits around the sun?
The sun is our star, our parent star. So that means that it's the heat and light from the sun that helps us to have life on Earth. Now, the sun is like any other star in the sky, but it's the one closest to us. And so because it's the one closest to us, everything in the solar system is held in its place because of the gravity of the sun. And everything in the solar system orbits around the sun. So that's the planets, the comets, the asteroids. All the different objects in the solar system are held together by the sun's gravity. So that's what we call the solar system.
I get it. Solar system, sun system. Neat.
Hi, my name is Maya. I'm 8 years old, and how old is the sun?
Hi Maya, thanks for your question. Well, how old is the sun? The sun is 4.6 billion years old, and that's actually the age of everything in the solar system because everything was formed at the same time.
4.6 billion?
Hello, my name is Ketia and I'm 8 years old, and my question is, how big is the sun?
Hi Ketia. So the sun, we know the sun is the biggest thing in the solar system. And we know that we could fill the sun with about 1 million Earths. So that's how big it is. But if you were to, for example, measure the diameter of the sun, so that's the distance from one side of the sun to the other side of the sun, then we would need about 109 Earths to fill that distance. So that's how big the sun is. Very big.
Yeah, very big.
Actually, even though the sun is really big compared to us, the sun is just an average sized star. So there are stars that are much smaller than the sun, and then there are other stars that are actually thousands of times bigger than our sun.
Whoa.
My name is Louis and I'm 9 years old, and my question is, how hot is the sun?
Hi Louis. It kind of depends which part of the sun, which layer of the sun you're talking about. So the temperature at the surface of the sun is about 5,600 degrees Celsius. So that is about 1,000 times hotter than your oven at home. And that's sort of layer of the sun we call surface. It's not a real surface like we have here on Earth. It's not a solid surface. It's a layer of the sun that we can see, and we call that the photosphere. But actually, if you travel to the core of the sun, so that's really right at the center, it's so hot that's millions of degrees hot. So it kind of depends on which layer of the sun you're talking about.
Hi, my name's Lottie, I'm 8 years old, and how much liquid's on the sun?
Hi, Lottie. Well, that is a really good question. But you know what? There's actually no liquid in the sun because the sun is made up of superheated gas called plasma. So there is no liquid because it's too hot for liquids to exist.
My name is George and I'm 8 years old, and my question is, how did the sun get its plasma?
Hi, George. What a great question. Well, when the sun was formed, all that stuff that made that nebula, most of it, went into the sun. And gravity pulled all of that stuff towards the center. So what that does is that as you start to compress things and things become sort of tighter, the space becomes tighter, and the mass or all that stuff is being pulled towards the center, it immediately heats up. As it heats up, everything around it becomes hotter and hotter and hotter. So that's where the plasma comes from. It's just because the sun is so hot that that's the only state that things can be in. So you have solid, liquid, gas, and plasma. So these are the 4 states of matter. And plasma is one of the states in which the gas has just become really superheated and electrified.
Hi, my name is Jessie and I am 8 years old. My question is, how long does it take to get to the sun?
So how long it takes to get to the sun depends on how fast you're moving, really. Because, for example, light is the fastest thing in the universe and it's the fastest thing in space. And light takes about 8 minutes to travel from the sun to the earth. So that's light, the fastest thing. What if we were walking? Well, if we were walking to the sun, which is about 150 million kilometers away, which is really, really far, then it would actually take us 3,500 years to walk to the sun. We don't want to do that because that's not a good travel plan. If we were to use a fast car, it would take about 176 years. If we wanted to go by plane, it would take 19 years. And if we were to use a really fast spacecraft, it would take us about, well, just over a year. So it really depends on your method of traveling, I guess.
My name is Olivia and I'm 8 years old, and my question is, how bright is the sun?
Hi, Olivia. The sun is not much brighter than many of the other stars in the sky, but it's the one that's closest to us. So it's our parent star, and it's about 150 million kilometers away from us. And all the other stars are really much further away, which is why they look so faint in the sky. But actually, even if you were to travel in the solar system, the sun would look differently depending on where you are. So if you were on Mercury, which you don't want to go to Mercury because it's really, really hot, the sun will be really bright and really big in the sky. But if you were to travel to the outer planets like Uranus or Neptune, the sun would look really small in the sky and it would look almost as bright as any other star in the sky.
Neat. But the sun is still so bright here on Earth. How can astronomers study the sun if they can't look at it?
That's a really good question, because you should never ever look directly at the sun because it can actually damage your eyes. So astronomers look at the sun by using filters. That's the technique we use today. So we use filters over telescopes so that it makes it easier or safe for us to look at the sun directly. However, a long time ago, before there were telescopes, people used projections of the sun to study the sun safely. So they would have mirrors and lenses so that the image of the sun could be projected onto a surface, and then you can study features of the sun like sunspots in that way.
Wow, that's so clever.
My name is Tina, I'm 9 years old, and my question is, how did the sun form sunspots?
Hi Tina, great question, and actually one of those questions that we at the observatory historically have researched. So you have the same mind as the astronomers do that worked at the observatory a long time ago. The sun is a really active place. It's really dynamic. All that stuff that makes up the sun, all that plasma, is constantly moving around. It's rising and sinking and flowing at different speeds because different parts of the sun move at different speeds. And what that does is that it creates a really strong magnetic field. The way to think of a magnetic field or if you want to visualize it, is to think of magnetic field lines like spaghetti. That's how I always think about it. So it's just lots and lots of spaghettis on the sun, and those lines, those magnetic field lines, they kind of twist and they bend, like bent spaghetti after you've cooked it for a bit. And what happens with that is that constant change of magnetic field creates a lot of activity in the sun, and in places where those magnetic field lines are kind of twisting around, the magnetic field becomes really, really strong in those specific places, and that's where then the plasma is kind of blocked out, making those specific spots much cooler than the surrounding area. And because they're much cooler, they appear dark to us. So we see sunspots as these kind of black spots on the sun, but actually they're just a little bit cooler, and they would be more like orange, really, if you didn't see them against the rest of the sun.
Wait, sunspots are orange? Is that because the sun is yellow?
The sun is actually white and not yellow.
The sun is white?
The reason why the sun appears yellow in the sky is because the light from the sun has to travel through the atmosphere to reach our eyes. And when the light from the sun travels through the atmosphere, all the blue parts of light get scattered around in the atmosphere. So the sun appears more yellow when it's high up in the sky, and it appears red at sunrises and sunsets. But if you were to go out to space, the sun would actually appear white, because the sun radiates or shines at all the colors of the rainbow. So when you mix all the colors together, it's white.
Hello, my name is Alfie, and my question is, how does the sun affect technology?
Hi Alfie, what a great question, because it's really relevant to today's technology, since we use Wi-Fi, internet, GPS, all sorts of things. So it's really important to understand how the sun affects our communications and our satellites. So the sun is a really active place, and it has this constant magnetic activity that create the solar storm. And during solar storms, the sun has these outbursts of energy and particle and magnetic fields and their radiations that go into space. When solar storms happen, the particles or radiation from the sun, all the stuff that the sun basically ejects into space, if it's directed towards the Earth, all of that stuff will then reach us and interact with our magnetic field. And the magnetic field of the Earth, you can think of it as a protective shield that protects us from a lot of the sun activity. But sometimes, if the solar storm is really severe, it can actually then affect the electronics in satellites, for example, and even actually radio communications and even power grids on the ground. So it really depends on how strong or severe that solar storm is. So that's why nowadays lots of agencies like NASA, or actually the Met Office, for example, they monitor solar activity and they monitor space weather so that we can know when these severe storms are happening.
Wow! Who knew the sun was so big and so hot and so active? Thanks so much, Tania, for sharing your knowledge with us.
Thank you to all the children at Beecroft Garden Primary School for all your fantastic and surprising questions that you had today about the sun.
Yes, thanks so much, everyone. And thank you for joining me today. I wonder what it would be like to move like the sun. If you'd like to float, pull, and spin, check out the sun's movement episode. But for the meantime, I'm going to sit in the sun for a bit. Don't forget your sunglasses. Until next time, bye! Thanks for tuning into Audiomoves today. If you loved learning these fascinating space facts, why not take it to the next level? Try one of our movement episodes and float on the moon, dodge asteroids, and soar through the stars right from your own home. Don't forget to subscribe, share with friends, and leave a review. If space has captured your imagination, you're in luck. We've covered loads of fascinating space-related topics in other episodes of this series. And if you enjoyed hearing from today's astronomer, why not take your curiosity even further? Check out the Royal Observatory in Greenwich. It's the perfect place to expand your cosmic knowledge. See you next time.